Okay, here we have another video with two more circuit components that are highly specialized and very interesting. Again, we're going to talk about these more later, especially these two, especially when we start talking about digital logic and how you can set up digital circuits with integrated circuits and things like that, and processors and so on. But for now, we're just going to talk about what these two components do. So this is a thermistor. It doesn't look like much. The action part is up here at the tip, and then these are two wires that would connect into the circuit down here. And then a light-dependent resistor right here. Again, those are the two parts that would hook into the circuit, and then up here is the business end of the light-dependent resistor, which is pretty much always abbreviated as LDR, light-dependent resistor. All right? So let's start with the thermistor. Basically, what does it do is the question, and the thermistor changes its resistance based on temperature. So this little guy up here is going to react to the external temperature, and depending on exactly how it's made up, it will react in different ways. But basically, a thermistor will react in general in the following way. As the temperature of that thing increases, higher temperature, its resistance gets lower. So this is essentially a resistor, but it's a resistor that's changing its resistance based on temperature. All right, this is the symbol of a thermistor. It looks exactly like a resistor to start with, so you would just draw a resistor and then add a hockey stick through it, just like that, through the center. A little straight part and then a line through there. It's related to temperature, and hockey, of course, is played in cold weather on ice, so perhaps that might help you to relate the symbol of the thermistor to the thermistor, in any case. So at higher temperature, the thermistor has a lower resistance, so that means that if the resistance is lower, you get more current flowing in the circuit. So basically, you get higher current with higher temperature in the thermistor. So temperature increases, resistance decreases, and you get more current. All right? That's the bottom line for a thermistor. Pretty straightforward. Its uses are very interesting. It can be used for temperature alarms or indicators or control circuits that are based on temperature, things like that. It's a very versatile device, but that's all we're going to say about it for now. Let's move on to the LDR. So the LDR, light-dependent resistor, changes its resistance based on light levels. So it's very similar to the thermistor in that sense, except it responds to light, not temperature. So the light-dependent resistor changes its resistance based on light levels that are incident upon the surface of the LDR. So here's the surface. You see these little squiggly lines. That relates to the functioning of the LDR. And that part is the part that has to be exposed to whatever light source it is that we want it to react to. So the symbol looks like this. It's just a resistor with a circle around it, and then two arrows which represent light rays. Those represent light coming in and hitting the LDR. You have to draw this whole symbol, otherwise it's not an LDR, including the arrows. Okay? Now again, similar to the thermistor, when there's brighter light, you remember the thermistor if it's higher temperature. In this case, it's higher light levels. So brighter light is going to indicate lower resistance. So if there is a brighter light shining on this surface, then the resistance of this guy is going to go down. All right? So lower resistance when the light is brighter. That means that when the light is brighter that is striking the LDR, or incident upon the surface, there will be more current flowing in that part of the circuit, or flowing in the circuit. So this thing's resistance decreases when light levels increase, and that means since the resistance decreases, that means that current increases. All right? So if light increases, resistance decreases, and that means that current increases. All right? So you guys are wondering why exactly are these useful? Well, a couple of terms in here, and then we'll explain briefly why they're useful. But I'll show you circuits that actually use these later. Okay, so why are they useful? They can be used in circuits that require a response to temperature or light inputs. So if you need the circuit to react to a certain temperature stimulus or a certain light stimulus, then you can use a thermistor or an LDR in your circuit, and they will react. Their resistance changes based on temperature if it's a thermistor, or light if it's an LDR. And that means that these components are called input transducers. All right, a transducer is something that changes energy from one form to another. So a transducer changes energy, changes the form of energy from one thing to something else. So an input transducer, in terms of electricity, is something that changes a certain input energy into electrical energy. So in both of these cases, the output is electrical energy, right? It's going to change the electrical energy of what is striking it in the case of an LDR, or its temperature in the case of a thermistor. So it's converting, an LDR is converting light energy into electrical energy, and a thermistor is converting thermal or heat energy into electrical energy. So the input energy is something that's not electrical in both cases. It's either light or heat. But the output is electrical. So you take a stimulus that is not electrical, and then you change it into an electrical response. So that is what they do, sort of in technical terms. How you use them, we'll have to wait and talk about that when we're talking about digital logic and digital circuits. But basically you can use an LDR or a thermistor to cause a circuit to react to different temperatures or different light levels. Perhaps you want street lights, a set of street lights to come on automatically when it's dark outside. That would be useful. You would need an LDR for that, something that reacts to light levels. So when the light levels get down to a certain darkness, then that causes the circuit to activate and the street lights come on to illuminate the surroundings because the sun has gone down. Possibly you want an alarm to go off if there is a fire in, that's not a great example. Let's suppose that you have a kiln for drying wood and it's not hot enough in the kiln. So you might have a temperature circuit inside the kiln that is set for a certain temperature. Let me write down what I'm saying here so that you can see it. The word I'm using is kiln, and it's used for drying out wood in terms of carpentry applications and so on. So say that you need that to be a certain temperature inside the kiln, then you could have a thermistor in there that is in a circuit that's set for a certain temperature, and if it's below that temperature, then an alarm goes off, or an indicator light comes on that says that it is not hot enough in the kiln. And then you would know, you'd be alerted, and you'd be able to adjust the temperature of the kiln so that it's proper temperature. Anyway, that's the idea. Don't need to go into any further into it right now. This video is long enough. So see you in the next video, and thanks for watching.